Okay, so this is a business logic in which this business logic is basically saying if we pass an integer value over here, it's going to divide that number by 2 until it gets a value which is less than 2, like which cannot be divided by 2 anymore. So it can be like this method is going to like return us the number of times it can divide. So for example, if we pass 15 over here, source number, and it should return us 3. If we pass 21, it should return us 4. To do that, we have written the business logic first, in which the logic is not there, it's hard coded, it's returning 0 initially. So it's not as per our logic, but we are going to write a test case or a test method which is basically going to test this method. So we'll test this method with different set of data, and we'll see if our test is passing. And initially the test will fail and the result is like something which is wrong. We'll try to put our logic over here so that the method is going to return us the perfect value. So let's do one thing. We should give an annotation at the rate test. It's basically a JUnit or TestNG annotation, which says that the method below is a test method. Public void test divisibility. Fine. Now this is the method which is basically going to test it for us. So this method is going to test this method, but before that we need to import this annotation. We need to add library JUnit or TestNG in to our project. Then only this project can be run. So let's do one thing. Go to Eclipse and right click on your project. Go to build path, configure build path. Go to libraries, add library. Here you will able to see different types of libraries available. So we're going to add JUnit library, or we can add TestNG as well. So let's go ahead and add JUnit and click on next. It will ask you which version you want to use. So any version will work for us. So we're going to take the latest one, JUnit 4. Fine. Now we have taken JUnit library. Let's click on apply and OK. Fine. Now JUnit is imported. So we're going to import the JUnit library test at the test annotation. So put your mouse on that. It will ask you to import org.junit. Look at this. Don't import anything else. It should import only import org.junit. Fine. Now we have imported and the error would be gone. Fine. Now it's okay. So you can see this is imported org.junit.test. So we have taken the test annotation and we have written a method. Now this method's work is to test it. So first of all, we should have one input. Whenever we test, we have a set of inputs and we have a set of expected outcomes. So if that doesn't match, then we say that the test is failing. Fine. So let's take int input equal to 15, then int expected output equals to 3. We know that if we have given 15, then we're expecting 3 to be the output. Let's do one thing. Let's call the method, and the method is going to give us the actual value. Okay, int actual value equals to, we're going to call the number of times divisible by 2, number of times divisible by 2, and we're going to pass the value that is input. Fine. Now this method is going to take 15 and we're expecting this method to return us some value, like that should be 3. Now what we are going to do here, we're going to check if the actual value is equals to the expected value, expected outcome. Fine, output. So if it is equal, then we can say that yeah, it works. Else we should say there is issue, we expected plus expected outcome and but received actual value. So now this is how it looks. So you may not be have access to this, like look at the source code, like how it works basically, but like this is part of the business logic, like business developer, they might have developed it. What you need to do, you need to write a method, write a test case. This is a Java test case, JUnit test case, which is basically you calling this method and passing the input and the expected, like it's getting the actual value. Now it's your duty to test if the actual and expected are equal. So we're going to put the logic, but before that, let's do one thing. Let's run the code and let's see if the business logic is okay. Right click. Okay. So initially the test should fail. Then we should make it passing by like writing the business logic. Run as. We should don't run a Java project because you won't get that, because you don't have a main method over here. You have a JUnit test. Click on JUnit test. So it's going to run that and it's going to show us. It's saying that there is an issue, or there is issue. We expected 3 but received 0. You can see one more thing in JUnit, it is saying that the test is passed. It's green. So JUnit says that the test passed, but it's wrong. We need to make this test case fail. How to do that? So we don't need to write all sort of logic. We have another way of writing it. So if you look at, there is certain, like there are certain methods in test JUnit which is going to help us assert the value. So we can do assert dot assert equals, and we can pass the expected value, expected output, and we can pass the actual value. So if they are equal, okay, this one is okay. We need to import it properly, otherwise it will give us a deprecation error. So let's do one thing, import it from org.junit. Now we have passed the actual expected output and actual value. Now it's task of JUnit to test if the values are equal, otherwise it will throw some error and it will fail the test case. Now the test case has passed, it would fail the test case. So there is one more implementation of this method. You can like basically pass the message. If it fails, this would show the message. So we need to pass the message first. If you go for integer, 1 second. Okay, and somewhere there. So we're going to pass some value over here, like the logic is wrong. Okay, so this message is going to come. So what it is doing, it is basically checking, asserting equality of both the values. This expected value, that is 3, and the actual value which is coming is 0. So it's checking if both of them are equal, then it will say okay, fine. Otherwise, if they are not equal, it will fail the test case and give the message logic is wrong. Let's run it again as the unit test case. Now we are going to see the output. It's saying the test case has failed. You can see it has said it has failed, and it has given some output. You can see the logic is wrong. The logic is wrong. 3 expected was 3, but found actual value is 0. So there is some method, there is some error in there. So basically the test driven development happens this way. So you first write a test case to test your logic, then we are going to see, okay, there is some mistake in our logic, let's make it right. Okay, now comes our logic. So what was the problem? What was the problem statement? For an input number, if it is 15, we are going to divide it until we get a value that is no more divisible by 2. So first of all, we're going to see, we're going to take a counter int, like the counter. So this counter is going to have 0 initially, like how many times. Till now we have not modified the value of counter. The counter is 0, like how many times it can be divided, that's 0. So at the end we are going to return the value of counter. Fine. Now we are going to put the logic so that the counter value is going to be incremented. What my like how I'm going to solve this problem is basically let's see. So we're going to take the value, initial value, that is 15. Okay, now we're going to do one thing, we're going to divide it by 2. So we'll get a result, like we get 7 and a remainder 1. We don't need the remainder, we can discard it. So we'll get the value 7. So in the next loop, so this is the first loop in which I'm dividing 15 by 2 and I'm getting 7. So when I did that, then what I'm going to check, if the remainder or the value that I have received, if that 7 is it greater than 2? So can I divide it? Yeah, or greater than equals to 2, because 2 is also divisible. So if this condition passes, that means I can divide that number again. So basically, after dividing the value by 2, I'm going to increment the counter is going to be incremented. Fine, then I'm going to check if the number can be like divided again. So if it's greater than 2, that's fine. Let's divide it again. 7 divided by 2. So now I'm going to get 3 and a remainder 1. I can discard the remainder. Fine. Now I have got 3. So I'm going to increase the counter again. Okay. So the value of counter now becomes 1, and here the value of counter becomes 2. Okay. Now the value becomes 2. Fine. So I have received 3 now. So what I'm going to do, I'm going to repeat the same logic again. So here I'll have a different sort of value. Here I'm having 3. Is it greater than equals to 2? Yes. So I'm going to divide 3 by 2 and I'm going to get a remainder as 1. Fine. Now I'm going to increment the counter. So I'll have the counter value as 3. Fine. Now the last value, the result was 1. So I'm going to repeat the step again. So I'm going to do both the steps. So first I'll take the if condition. I'll check if 1 is greater than equals to 2. No, it's not equals to 2. So at that point of time, I'm going to return the counter value. So this is the way I'm going to basically solve it. And every time I'm going to, this is the source value. So 15 is going to be replaced by the result that we have received. Fine. So that in the next loop, when I'm going to divide it, the number, that's no more 15, that's 7, that's 7 now. Again, when I've divided 7 by 2 and I have received 3, I'm going to update the source value from 7 to 3. Because when next time when I want to divide 7, when I'm going to divide the source value, that's no more 7, that's 3. So that way I'm going to solve it. So let's do one thing, let's keep this thing apart. Let's write our logic over here. Fine. So I'm going to use a while loop now. Because in while loop I'll have the condition as if the number is greater than equals to 2. So that every time I can check it. So first of all, let's do while, and over here I'm going to put the logic. Source number is greater than equals to 2. That means if the source number can be divided by 2. Fine. If it is true, and remember we're using while, not do while, because in do while the loop is executed at least once. So if the loop is getting executed, then our counter value will be incremented. But if somebody is giving the source number as 1, then we cannot divide 1 by 2. So that's the reason we should return 0 at that point of time. So we should not enter the loop. Now if the source number is greater than, so initially I need to put the logic, I need to check if the source number is greater than equals to 2, then I can divide it. Then what I'm going to do, I'm going to put the logic source number divide by 2. So what it is going to give me, it's 15 by 2, it's going to give me 7. So but I need to have that 7 back, right? I need to update the value of 7. So I'm going to have source number, I'm going to update the value of source number to the newly generated number over here. So what it is going to do, it's going to divide 15 by 2 and it's going to get 7, and it's going to update the result, it's going to update the value which it has returned, that is 7, to source number. Fine. Now after this is done, then I have divided it once, so I'm going to increase the counter value. So the loop will continue. Every time the loop comes over here, it is checking if the source value, if the source number is greater than equals to 2. Now the value is 7, that's greater than equal to 2. Fine. Now let's update this 7 divided by 2, that's 3, and source becomes 3, and it's incrementing the counter from 1 to 2. So this way it is basically doing the operation, and at the end when the loop is done, I'm going to return the counter value. So I think this is done. Let's check the result. Okay, now it's fine. So how am I going to do? I am going to check the result now. I am basically going to run my test case with the expected value. and I'm going to check it. Fine, I have formatted the code now, that's fine. Let's run it. I have given 15 and I'm expecting it to return 3. Let's run this code, right click, run as JUnit test. See, it is saying, yeah, it has passed. So, okay, for one value it has passed, okay, because there is no output. I have not printed anything on the console. You cannot see any sys out. It is just the JUnit test case which is saying well, it has passed. So let's do one thing. Let's change the value from 15 to value 21. But when we're giving 21, we should be expecting the value to be 4. So let's run it with different set of data. Run as JUnit test. Now again it has passed. If you expect something else, if you expect 3, it's going to fail, and it is going to show you that I was expecting something and you have given me something else. The logic is wrong. I expected 3 but I got 4. The actual value is 4, the expectation was 4. So it's saying the test has failed. Then you are going to check, okay, the logic is proper but the expectation, this value, it was wrong. So now you're going to make it 4. Fine. So this is how we need to basically solve the problem statement with test driven approach.